Okay, so today we will be solving neighboring bitwise XOR. This is Leetcode POTD for 17 January. So we are given a zero index array derived with length n is derived, or zero index array derived with length n is derived by computing the bitwise XOR of adjacent values in a binary array original of length n, specifically for each index I in the range 0 to n minus 1. If I is equals to n minus 1, then derived of I equals original of I XOR original of 0. So basically we have an array. So basically we have an array, right? We have an array and this array is called derived. Basically if we had A, which is the original array, then derived array is AI XOR AI plus 1. And this array is cyclic. So we have A1 here and AN here, and then there will be A1 here. So that's what they are saying. When I is equals to n minus 1, the derived would be A of I XOR A of 0. So what we have to do is, given an array derived, your task is to determine whether there exists a valid binary array original that could have formed derived. Return true if such an array exists or false otherwise. Okay, so let's see what happens. So we have a valid binary array original. We have to find that out. So we are talking about binary arrays, right? So in binary arrays, you know that XOR can only take two values. Either the XOR would be 0 or the XOR would be 1, right? So if you are given a derived array such that, let's just say this is 0 and this is 1, right? So we have to construct an original array and we have to tell that if it's possible to construct. So we know that A1 XOR A2 and A2 XOR A3 all the way up to AN XOR A1 equals some values that are given to us. Okay, so 110 in this case, and A3 XOR A1 equals 1 1 and 0. So we know that the XOR of these two values and XOR of these two values is 1 and 0, right? So the only possible way this could happen is if A1, let's just say, is 0, right? So we can only have two values for A1, right? Either A1 is 0 or A1 is 1, right? Either way, this can be used to find out A3. So what we will do is consider A1 equals 1. We'll move on and find out A3. Then this can also be used to find out A2 because that is how it is done. So we can just consider two values for A1 and then see if there is a valid array or not. Right, so let's see. If you consider A1 as 0 here, so we have 1, 1 and 0. If you consider A1 as 0, then A2 would be 1 and A3 would be 0. And this is actually, and A3 would be 0. And then if you calculate the derived from here, it's actually good. But if you consider A1 as 1, then A2 has to be 0, right? And A3 has to be 1. And this is also gonna work because this would be 1, this would be 1, and this would be 0. So this is okay. So we have to just check if it can exist. For example, for 1 0, right, we have A1 as 1, so A2 will be 1, or it would be 0. And if it's 1, then it would be 1. So this is how it is, and we can see that none of them works really, right? So yeah, that, let's check. First of all, let's go the length of the right. You can construct maybe this um, TMP, like the TMP of 0 equals 0, hmm? 99 into 99, hmm? TMP of hmm? TMP of I equals, we have to see, like TMP of 0 is 0, so this would be if you want to make it 1, right? So basically it's like TMP of I minus 1 and some value equals derived of I, maybe, yeah, I plus 1, I think I should do it here. So basically value would be this, it's not derived. Hmm. So we can just go from here to here, TP of I plus 1. So we know derived, right? We know this. We have to find out this value. We oh okay, okay. We know this derived, and we know that this value is nothing but um is one XOR TMP of I. This has to be equal to derived. If TMP of I plus 1 would actually be equals to derived XOR TMP of I. Hmm? So yeah, so here TMP of 1 would be equals to 0 XOR 1, which is 1. TMP of which is 0. This is and that is 1 2, right? Mm, 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 mm. We don't even need this. What we can do is like create a value variable here. And then we can just update value. We to value XOR derived of I. And then again value w equals derived of n minus 1 because we're taking that. So we return true. Otherwise we can also check this with a value 1, or maybe we can do this simultaneously. And value double equal of n minus 1 for the value to XOR one because that interesting. Isn't this value just isn't this value just this? Because yeah, I think if it works with zero, they're also going to work with one. They're both cyclic, so there's no need to check for one, I think. Because if zero works, then it will also work for one. Let's see. Yes. Hmm. Yeah, so that's all we have to check. Because if an answer exists for zero, the answer exists for zero. If answer exists for zero with a of zero at zero, then it will also exist. It will also exist for a of zero equals one. This is true because well, this is true because in the end we have to check a of zero XOR a of n minus one equals derived of n minus one, and we know that a of zero is one, right? XOR a of n minus one equals derived of n minus one. So this value that we have, right? Mm, initially we have to do this, and similarly this would be a of n minus one equals derived of n minus one. So this is true because of the way a of n minus one is constructed. As we can see here, the way a of n minus one is constructed here, it will have a of 0, 1 value contributing to it. So this would be nothing but 1 XOR 1 XOR a of n minus 1. And if I do this, this would just be the same. Another way to see it is like, um, yeah. So what we can do is basically find out for a of 0 equals 0, the value, the value, because a of 1 would be nothing but a of 0 times derived, right? A of 0 XOR derived of 0. Why is this true? Because we know that a of 0 XOR a of 1 equals derived of 0. So a of 0 or a of 1 would be derived of 0 XOR a of 0. So we have this value, and similarly a of n would be a of n minus 2 XOR, or specifically it would be a of n minus 2 XOR a of n minus 3 all the way up to a of 0 XOR derived of n minus 2, right? Because we know that a of 2 equals a of 1 XOR derived of 1, and a of 1 is nothing but a of 0 XOR a of 1 XOR derived of 1 XOR derived of 0. So here this would be derived of n minus 2 derived of 0. So we can see this is nothing but the XOR of all the values in the derived XOR. So if you see, right, if we have all these values, so this is nothing but the derived till the last value, and then we have to just check that this value that we have is equal to derived of n minus 1. This is what I did. So if we XOR both the sides, this would be the XOR of whole derived array, and this would be 0. So all we have to check is the XOR of derived array is 0. If that is true, then it's true. Does this hold? Let's see. This is a new thing that we have discovered while trying to prove that the answer exists for both. So we just have to do value equals value, and let's just see that return not open. Let's see if it works. Yes, it works. So all we have to check is the XOR of this array is 0, as we have proved it. We divide both sides in. Yes. So that was the problem. I think it was a pretty good problem. I really enjoyed it. I really enjoyed proving it. And yeah, that is all for today's POTD. Thank you so much.